So the first case for asymptotic behavior was a horizontal asymptote y equals 0 when the degree of the denominator is higher than the degree of the numerator. So case number 2 is when the degree of the denominator equals the degree of the numerator. And then the asymptote for that will be y equals a over b. It's a horizontal asymptote, y equals a over b. And it will not be 0, so it won't be the x-axis. Where f of x equals a x to the n plus dot 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 over b x to the n plus dot dot dot. In other words, a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. And this happens again because the dominant terms as x goes to infinity or minus infinity are the leading terms of the polynomials. Okay, so here's an example. F of x equals 3x squared plus x minus 1 all over 2x squared plus 1. As x goes to plus or minus infinity, I'm just going to do them both at the same time now. F of x goes to the strongest terms for large values of large magnitude x, which is 3x squared over 2x squared. You can reduce that to 3 halves. So f of x goes to the horizontal line y equals 3 halves. Remember, f of x is y here. So y approaches 3 halves. So the line y equals 3 halves is the horizontal asymptote. Okay? So that's how all horizontal asymptotes are either the type 1 on the previous video or page or type 2 on this one. So note, we can also get this result by long division, as in the next step we'll do, the next case on the next slide or page or video, depending on what you're looking at. I have these on PowerPoint, which would be a slide. I have them in PDF, which would be a page, and I have them here in video, so never really sure which one to use. So, which term to use. So we get this horizontal asymptote at y equals 3 halves, which is 1.5, right, of course. And then I just picked some points and drew a graph. Now, the smart thing to do would be to pull out your calculator and see what it looks like before you start messing around with it. This doesn't have any vertical asymptotes. You can tell because if you look at the formula, set the denominator equal to 0, and first of all, it doesn't factor with real numbers, right? So you set it equal to 0, and you solve, and you'll see that you get plus or minus the square root of negative 1/2, which is not a real number. And the graph is in the real plane, so that we're only graphing real numbers. So there's no vertical asymptote in the real plane. So I just graphed a few points. Right. This point here is really important, but it's called a local minimum. It's actually a global minimum, but you can find those easily using calculus, so I'm not going to worry about how I found that. You could use a min function on your calculator if you know how to do that, calcmin or something like that. But I just sort of approximated it, I believe, which you can do by like zooming in on that point or something.